Alaikum warahmatullahi wabarakatuh. This is Miss Linda. Today, inshallah, we're going to solve IB past paper exams, paper 1. We're going to start from May 2022, and then we continue with the IB practice questions that I shared with you on Google Drive. So we're going to start first with paper 1, last year exam, 2022. Only the question that is related to mechanics we're going to solve today. Now, the first question. The radius of a circle is measured to be, so here we have R. This is the radius. The first one is the original, and the second one will be the uncertainty. What is the area of the circle? Now, we know area is pi times the radius square. So this will equal pi. R is 10 square. I'm not going to convert to meter because the answer they provided to us is all of them centimeter square. So I'm going to keep everything in the same unit, centimeter. And this one will be 314 centimeter square. Now, how can I calculate the uncertainty? Since I have here multiplication and I have power, so the uncertainty in the area, I have to find the percentage or fractional uncertainty. So fractional uncertainty in the area will be the uncertainty divided by the original area will equal pi is constant, so we can ignore it. R to the power 2, we'll get the 2 out. Be the uncertainty in R divided by R. Or we can say delta R over R plus delta R over R, the uncertainty in the radius divided by the radius twice. So this will equal to delta R is 0.5. The original radius is 10. And this will give us 0.1. So if I need the uncertainty, not the fractional uncertainty, so it will be delta A divided by the original area, which is 314 equals 0.1, cross multiplication. So delta A, the uncertainty will be 31.4, two significant figure, 31, so the answer is D. Second question, you have two different experiments. The first experiment B and second experiment Q generates two sets of data to confirm the proportionality of variables X and Y. Now, when you have two variables X and Y proportional to each other, you should get straight line, and the straight line should pass through the origin. Okay, the graph here, you have maximum and minimum gradient line, maximum and minimum gradient line for both data. Now, first, this one, the graph B, I have the first one is steeper. If I call this one line 1 and line 1, line 1 is steeper than line 2. There is range, the range between the gradient is minimum, is not that big. While in the second experiment, the range in gradient is huge compared to B. So the uncertainty in gradient, they're larger for set A. Let's go back to the systematic error. Now, systematic error, we learned that it's due to the instrument being out of adjustment. You haven't calibrated to start from 0, for example. If you have a voltmeter device or digital or analog device, it might has a 0 offset error. If you're using meter stick, it might be rounded to one end, not to the other. If you're reading, if you're taking a measurement from a tube, maybe the reading you're measuring is not from the top of meniscus when you, for example, measuring the volume or the height of water or height of any liquid. So how can we know that systematic error? Always y-intercept is the key factor to indicate the systematic error. So if I look to the first one, B, here, and the second one, this one is almost, if you extend this line, is about to reach 0. So the systematic error for Q is less than the systematic error here for B. So B is larger systematic error because it doesn't start from 0. It's not calibrated. Maybe the experiment is not being calibrated. It doesn't start from 0. Now, question number 3. You have a road from city X to city Y. The total distance is 1,000 kilometers. Now, what is the difference between distance and displacement? Distance is a scalar quantity, while displacement is a vector quantity. Distance in many cases is either greater than or equal the displacement. When we measure the distance, we are following the total length of path traveled. So from here till here, the total length of path traveled. While the displacement, I don't care about the path travel. I cared about from where I start to where it ends. So from the starting point, I start from here. It ends here from the starting point to the end point. So it's the shorter path, the change in position from the starting point to the ending point. Now, since it's a vector quantity, so if I go from X till Y, it will be positive. If I go from Y till X, it will be in the opposite direction, it will be negative. So displacement, it will be negative 800 if I go from Y till X. So the correct answer, it will be negative 800, while the distance is 1,000. So the correct answer will be D. Now, question number 4. You have a car, accelerates uniformly from rest. So the initial velocity here, 0, to a velocity v during t1. So I start from initial velocity 0. During time t1, the velocity v. Then it continues with a constant velocity. This is multi-legged journey. So, and again, we'll continue with the same velocity v at time now t2. What will be the total distance covered? Now, the first leg, I have to find the first distance, delta x1. Second leg, from here till here, I have to find delta x2. The total distance will be delta x1 or x1 plus x2. Now, how can I find the distance? The change in velocity, initial plus final, divided by 2. This is the average velocity, times time. I start from 0, initial, and v, so it will be half v times t1. Now, delta x2 or x, or we can call it s, since the dB, they don't use delta, so we can call it s. This is s1 and s2. Yeah. So this is S1, and here S2, S1. Now S2 will be the initial velocity times time. Time will be the change in time plus half acceleration times change in time squared. The initial velocity in the second leg, it will be V1. It will be V times change in time will be final minus initial. Since it moves with constant velocity, this velocity is constant, so I will not have acceleration. The acceleration is 0. So this part is 0. So if I need to find now the total displacement, I have to add S1 plus S2. So if I add S1 plus S2, will be half V times T1 plus V times T2 minus T1. This is the total distance or total displacement. So the correct answer is D. Question 5, you have inclined surface, inclined plane. You have an object is sliding from rest on frictionless incline. Frictionless, that means I don't have a friction. So if I'm slides 1 meter during the first second, what will be the distance during the second second? So during the first second, I'm going to write all the information I have, so that equation. So the distance is 1 meter. The initial speed start from rest, so 0 meter per second. Final speed, I do not have it. I don't have the acceleration, so I'm going to write question mark. And the time is 1 second. So to use that equation, S equals U initial times time. When we write time, it means a change in time. Okay, and when we write distance or displacement, it means change in distance, and final minus initial, plus half acceleration times d squared. Now distance is 1, initial speed, this side is 0, plus half acceleration times 1 squared. Cross multiplications, so we have the acceleration is 2 meters per second squared. Now the velocity, V final, will equal U initial plus acceleration times time. This is another equation, so that equation. Initial velocity 0, acceleration now is 2 times 1. So V final here is 2 meters per second. Now during the second now, I do not have the distance. I need to calculate the distance. So this is a question mark. U initial, it will be the same as V final in the first second. So it will be 2 meters per second. V, we do not have it. Acceleration is 2 meters per second squared. And time is 1 second. So I'm going to use that equation, which is this one. S will equal U initial 2 times 1 plus half acceleration 2 times 1 squared. So this one will be 3 if you calculate it 3 meters. So the correct answer is C, 3 meters. Now question number 6. Here. Okay, you have an object. It has mass 2 kilograms. Rest on a rough surface. That means I have a friction. A person pushes the object in a straight line with force 10 Newton. So this is the applied force. The object will move a distance d. The resultant force acting on the object is 6. Now, since I have acceleration and the object is moving, this will be the direction of motion or direction of acceleration. I'm going to draw all the forces acting on the object. This is the first thing to do when you solve questions that is related to motion. It has forces and motion. So here I have applied force. Since it's rough surface, opposite to the direction of motion, I will have a friction, and it is dynamic friction. Direction of motion to the right. So I'm going to apply Newton's second law. All the forces acting on the object will equal mass times acceleration. Now, all the forces, what are the forces that are acting on the object? In the same direction of motion, these forces will be positive. Opposite to the direction of motion, it will be negative. So I will have the applied force minus the dynamic or kinetic friction. I know the summation of all forces acting on the object, or the net force, is 6. So this is 6 will equal 10 minus the dynamic friction is the coefficient of kinetic or dynamic friction times the normal force. Now from here, I have the weight of the object down, and the normal force is opposite to the weight, perpendicular to the surface. So Fn is the same as the weight, which is mass times free fall acceleration. So this will be equal 6, will equal 10 minus, I do not have a mu. Okay, mu d times Fn, the mass is 2, times free fall acceleration, I can consider it 10. I can consider this one 10. So it will be 2 times 10. If you calculate this one, you should get mu d. Take this to the other side. Okay. So it will be negative 4 divided by 20. This will give me negative 4 divided by negative 20. Negative and negative, they cancel out. So you will get 0.2. There is no unit. So 0.2 here and here, A and B, both of them, we have 0.2. Now I need the acceleration. Let's go back to Newton's second law. F, all the forces acting on the object, F net, or all the forces will equal mass times acceleration. The forces acting on the object, or the net force, is 6. Mass of the object 2 times the acceleration, divide both sides by 2. So the acceleration will be 6 divided by 2 will give us 3 meters per second square. So this one, the correct answer is A. Okay, number 7, you have a rocket. The rocket has just been launched vertically from Earth. So the direction of motion is in the vertical direction, y direction, up. The image shows free body diagram of the rocket. You have F1 and F2 represents a larger force. F1 is a larger force than F2. Now, what are these forces? F2 is the weight of the rocket. The weight of the rocket down, it's the weight by Earth exerted on the rocket, and which is equal to the weight of rocket on Earth. Now, F1 is the this one is the propulsion force, which is the force exerted by the gas itself when it starts burning on the rocket. For every action, there is the second, third law. For every action, there is opposite and equal reaction, which equal also the force exerted by the rocket on the gas. Now, which pairs with F1 and which force pairs with F2 according to Newton, third law? So you have here force of rocket on the gas. This is with F1. And gravitational force of the rocket on Earth. This is what F2. Now, question number 8. You have an object is pushed from rest. So the initial speed here, U, is 0, pushed from rest, with a constant force, constant net force. So this is F net, or is the same as all the forces acting on the object. When the object has traveled 2 meters, so this is S, or delta X, has reached a velocity, so the V final is 10 meters per second. I need the mass of the object. This is Newton's second law. But to apply Newton's second law, first I have to find Newton's second law, F net, or all the forces acting on the object, is equal mass times acceleration. I have to find the acceleration force. I have the forces acting on the object. but I don't have the acceleration. So first step, I have to find the acceleration. I'm going to use SUVAT equation. V final equals U initial plus, since I don't have time, we're going to use the timeless equation. So plus 2a times the displacement, S or delta x. This is 10 squared, 0, plus 2 times, I do not have the acceleration, distance is 2. Okay, so I need the acceleration will be 100 divided by 4 will give us 25 meter per second squared. Now I can use Newton's second law. F net, it's 100 equals m mass times 25. Divide both sides by 25. So m will be 100 divided by 25 will equal 40 grams. So the correct answer is B, 4 kilogram. Now question 9. This is the last question in mechanics. Okay, question 9, you have 2 blocks. They have different masses are released from identical springs. Identical springs means we will have the same constant, the same spring constant. The elastic constant K is 100 Newton per meter, initially compressed. So you have a spring. This is I compress the spring. I push the spring inward. So the spring will be compressed. The distance here, how much? 0.1 meter. Block A has mass. We have a block X and we have a block Y. X, it has mass 1 kilogram and Y has mass 0.25 kilogram. What are the velocities of the blocks when they leave the spring? Now, we're going to use the conservation of energy. Energy initial equals energy final. Okay, since we do not have a place, let's solve this question. Okay. We'll do it here. What is the conservation of energy? Conservation of energy, the initial mechanical energy will equal the final mechanical energy. The general formula for conservation of energy is the work applied plus the kinetic energy initial plus the potential energy initial equals kinetic energy final plus potential energy final plus the energy lost due to friction. Now I don't have work applied and I don't have energy lost. The initial energy was kinetic. The initial energy, sorry, it was potential energy and it's elastic potential energy. The object wasn't moving, but it's compressed at the beginning. So potential energy. And then the object start to vibrate. The mass spring system start to vibrate back and forth, so I will have kinetic energy. So initial energy is elastic potential energy will equal the final energy is kinetic energy. This is the initial equals final. Elastic potential energy is half K times the displacement. Displacement delta x squared will equal half m times velocity squared. Half and half they cancel. I'm going to apply this formula for mass x and for mass y. So for mass x, K is 100. Displacement is 0.1 for both of them squared will equal mass is 1 times v squared. So from here, you will find v, if you take square root for both sides, it's 1 meter per second. Now for object y, same formula, K is 100 times delta x is 0.1 square, 0.1 square times equal m 0.25 times e square. Okay, so take square root for both sides, b, divide both sides, by 0.25 by 0.25, and then take square root for both sides. So V will equal 2 meters per second. So velocity of a block Y is 2. Velocity of a block X is 1. Now, my students will continue now with the worksheet I shared with you in Google Classroom. The worksheet is topic 2, mechanics, paper 1 IB practice questions. Okay. First one, you have two forces act along a straight line on an object that is initially at rest. One force is constant, the second force in the opposite direction. To what is the correct about the motion of the object? The velocity increase since I have forces. And here I have varying forces. The velocity will increase from 0 till it reach the maximum 1. Let's go to question 2. Question 2, you have a variation with time of the acceleration of an object is shown. What is the change in the velocity of the object? When it's given to you, acceleration versus time, and they ask you about the velocity, you need to find the area under the graph. Acceleration is a change in velocity divided by change in time. So if I need the velocity, is acceleration times time. Velocity is acceleration times time. That means I have to find the area under the graph. So I'm going to call this one area 1, here area 2, and here area 3. So the total area, the area 1 plus area 2 plus area 3. Area 1 is length times width, because it's a rectangle. So it will be 2 times 1 plus area 2 is rectangle again, length times width. From 2 till 6, the difference between them is 4. So it will be 4 times length is 1. This is 1. Plus area 3, it's triangle, so it will be half. The area of triangle, half base times height, half. The base is this distance, it will be 4 times the height. From 1 till 3, the difference between them, 3 minus 1 is 2. So if you calculate all of these, you should get 10 meters per second square. This will be the acceleration. 10 meters per second. This is the velocity, meter per second. So this will give me the value of V. So the correct answer will be C. C, 10 meters per second square. Our question number 3. You have a climber, has mass M, slides down a vertical rope. So the direction of motion is down. Okay, here's the climber. I'm going to draw always free body diagram. The object, to draw it as box, small box or circle. The direction of motion is down. So this here is direction of acceleration or motion. With average acceleration A. The average, there is a friction always direct opposite to the direction of motion. I will have acceleration. What are the forces acting on the climber? I have his weight down, mg, and in the rope up, I have a friction force, F dynamic or F kinetic friction. These forces are opposite to each other. So what are the net forces? F net. Direction of motion, the forces in the same direction of motion will be positive. Direction of motion, direction of acceleration. Opposite to the direction of motion is negative. So it will be mg minus mg minus the friction force. Now, I need to find the value of the average frictional force. Now, from Newton's second law, F net, or all the forces acting with the object, will equal mass times acceleration. So substitute here, will be MA equals mg minus the friction force Fk. Take this to the other side and multiply by negative both sides. So Fk will equal mg minus ma. Take m as a common factor outside, so it will be g minus a. So the value of kinetic friction will be m times g minus a. Now, question number 4. Okay, you have a cube. The cube slides down the surface of a ramp at constant velocity. Constant velocity means acceleration equals 0. This is a Newton's first law. What is the magnitude of frictional force act on the cube? So if you have a frictional force inclined surface, I'm going to draw the free body diagram of the object. I'm going to draw the object as box or circle. The weight of the object down, perpendicular to the surface. So this is the surface. I have the normal force. The object slides down. So direction of motion, acceleration in this direction. Opposite to the direction of motion, I have dynamic or kinetic friction. I'm going to break down Fg, the weight, into two components. One component in vertical direction is the same direction as Fy. This is vertical direction, y direction. And the other one, it will be in the x direction. Horizontal direction is parallel to the surface. So this is the horizontal direction. Always the component of the force in the vertical direction is the cosine, it's adjacent. So this is Hg cosine the angle, and this will be Hg sine the angle. So the component of the weight of the cube, which one will equal the frictional force? This one, the component of the weight of the cube, parallel to the plane. Parallel to the plane. Okay, I'm going to continue with the next video. Inshallah, I'm going to